Hi, okay, let's do a speed ratio calculation. All right, so speed ratio is another way that we can analyze how well a machine is doing its job. Speed ratio typically compares distances. It compares the input distance with the output distance, again, just like forces with mechanical advantage. And the input is the distance that the person has to move or apply their force over while they're using that machine. And the output distance is how far the load ends up moving by the machine. Okay, so you're looking for those two variables in whatever question you're dealing with. Now, because friction is never really affecting distance, it's a force, we don't really even consider friction here when we're doing speed ratio, but we'll talk a bit more about that when we do an efficiency calculation. So really, if we just ignored friction altogether, the relationship between speed ratio and mechanical advantage is they should come out to the same number. Okay, so if you're, like on our mechanical advantage, we came out with a mechanical advantage of 5 in the other video, that would mean for that machine to be multiplying force 5 times, the person must be moving 5 times further than the load moves. Okay, so that's always the trade-off. In order to get a force help, you'll have to apply that lower force over a longer distance. All right, so because of that, the formula that we use puts input distance on top this time and output distance on the bottom. Okay, so let's look at a sample. Hans tree branch trimming machine needs to be moved 0.5 meters to cut a distance of 0.2 meters. Calculate the speed ratio. All right, so the machine itself has to be moved this far in order for it to cut only this far. So I know we don't have too many names or really keywords identifying things, but it sounds like the person operating the machine has to move it 0.5 meters. That would make that our distance input by the operator, whoever's using the machine. The output distance is how far that machine moves in that whole movement. So that would be the output distance. Okay, so once we've done that mental work, we can go ahead and write the formula. Die over dou, 0.5 meters this time, divided by 0.2 meters. Okay, the meters cancel out in my calculator. 0.5 divided by 2, it comes out to 2.5 or 2.5. All right, so the person operating the machine has to apply their force 2.5 times further than the machine actually moves the load. And that's fine because they're getting a force advantage in this case. All right, so in a perfect situation, that machine should also be multiplying force by 2.5 times. All right, but you have to watch the efficiency video to hear a little bit more about that relationship. Good luck.